This was what we call a volcanic explosivity index 6 eruption.
Scientists have discovered the true ferocity of a huge volcanic eruption.
What if I told you that NASA has made a shocking discovery that could change the course of our planet's history forever? Yes, you heard me right. Today, we're delving into NASA's jaw-dropping revelation about the world's largest volcano and the impending eruption that could reshape our world. Mount Peck 2, also known as Chiangbai, is a big and dangerous volcano located on the border between China and North Korea. It's one of the biggest volcanoes on Earth. Despite its grandeur, scientists couldn't figure out why such a massive and destructive force of nature exists in this remote part of the world. Most volcanoes are usually found where tectonic plates collide, creating subduction zones. These zones happen when heavy oceanic plates go beneath lighter continental plates. This causes molten rock and earthquakes, leading to volcanic eruptions. Mount Peck 2 doesn't fit the usual explanations for volcanoes. It's different from the others and challenges what we know about Earth's geology. To understand it better, scientists came up with a new idea called the mantle plume model. This theory says that some volcanoes are powered by hot molten rock coming up from deep inside the Earth. But Mount Peck 2 has a surprise. Recent research shows it's not a typical hotspot. Instead, it's a special kind of volcano called a black arc volcano. Its origin is linked to a plume of water and molten rock rising from a place called the Mantle Transition Zone. This is all connected to the Pacific Plate going under Northeast Asia. This discovery has opened up a lot of questions for scientists. They are now looking into how water affects volcanoes and the importance of the Mantle Transition Zone. So, what are these scientists worried about? And what secrets does Mount Peck 2 hold? Let's explore. The eruption of Mount Peck 2 was incredibly massive. When it erupted 1,000 years ago, it released a huge amount of material, more than 100 cubic kilometers. To put that into perspective, it could bury entire villages in northern Japan, which is over 1,200 kilometers away, under a thick layer of ash. This eruption was so powerful and large that it's considered the second largest volcanic eruption in the past 5,000 years. It's classified as supercolossal in the Volcanic Explosivity Index, showing the immense energy and destruction it caused. After the eruption, it left behind a stunning feature called caldera. Mount Peck 2's caldera covers a massive 20 square kilometers, making it one of the biggest calderas on Earth. It shows just how much force came out of the volcano, reshaping the land. The impact of this colossal eruption was felt far and wide. Villagers in northern Japan, over 1,000 kilometers away, were covered in ash. The eruption also produced pyroclastic flows, which are superheated gas and debris avalanches that traveled up to 50 kilometers in all directions. The destruction was so extensive that it covered an area the size of Tokyo. Even though this eruption happened 1,000 years ago, we can't ignore its significance. Today, more than 1.5 million people live in the immediate danger zone of the volcano. Mount Peck 2 is still active, and while it has been relatively quiet recently, scientists know we need to keep studying and monitoring it to understand its behavior and reduce potential risks. This supercolossal eruption of Mount Peck 2 reminds us of the incredible power of nature and how unpredictable it can be. Most volcanoes are found at places where pieces of the Earth's outer shell, called tectonic plates, meet. These meetings often create what we call subduction zones. Imagine these zones like a wrestling match between two plates. A heavier oceanic plate gets pushed beneath a lighter continental plate. This tussle leads to volcanic activity right where the plates meet. The Pacific region, known as the Ring of Fire, is a great example. It has about 80% of all active volcanoes on Earth because of these subduction zones. Now, here's where Mount Peck 2 gets interesting. It doesn't fit the usual model of a hotspot volcano. Hotspot volcanoes are powered by hot molten rock from deep inside the Earth. But Mount Peck 2 doesn't behave like a typical hotspot. Its location in a remote part of Asia, on the border between two historically isolated countries, adds to the mystery of how it formed and works. If you are enjoying this video, don't forget to subscribe to the channel. Seismic tomography is a technology initially developed for medical purposes, but has revolutionized geological research. It works by using seismic waves created by earthquakes to make detailed pictures of what's inside the Earth. Geologists use these images to explore what's going on hundreds or even thousands of kilometers beneath the Earth's surface. Seismic tomography has been incredibly helpful in understanding Mount Peck 2. It showed something unusual in the mantle transition zone beneath the volcano about 600 kilometers below the surface. The zone had a big patch of very cold material. Further investigation revealed that this anomaly was actually a piece of ancient crust from the Pacific Plate. After the Pacific Plate goes under, it kind of gets stuck in this layer that separates the upper and lower mantle. The interaction between this stagnant chunk of plate and the mantle transition zone is what creates the unique volcanic activity at Mount Peck 2. This volcano has shown us something important about a layer deep within the Earth called the mantle transition zone. Before, this zone didn't get much attention, but Mount Peck 2 has put it in the spotlight. One significant discovery is the existence of wet upwellings in this zone. These upwellings are connected to oceanic crust going under and getting stuck. They could explain many cases of volcanic activity between continents, which we see all over the world. This new insight challenges what we thought we knew and expands our understanding of the processes that cause volcanoes. The role of water. Water is a big deal in volcanic eruptions, and we used to underestimate its importance. Now, we know it plays a vital role in the mantle transition zone. It not only affects the power and type of volcanic eruptions, but also contributes to how water moves around the planet. By unlocking the mysteries of Mount Peck 2, scientists have gained a deeper understanding of how different parts of the Earth work together. This knowledge isn't just about one volcano, it has broader implications for all volcanoes worldwide. It's making us rethink our old models and theories. Mount Peck 2, with its huge size, unique volcanic activity, and mysterious origins, has intrigued scientists. Thanks to advances in seismic tomography, we're getting a better grasp of what makes it special. The hydrous plume theory offers a new way of explaining this black arc volcano, challenging the traditional hotspot model. What do you think of this mighty volcano in China? Let us know in the comment section below, and make sure to like the video. Thanks for watching.